So properties of limits. We have this function here, and the question is asking us to find the limit of x as it approaches 2 in this polynomial. Now, technically with the properties of limits, we would break each of these values and find the limit of all three of them. The limit of any constant is the number itself. Okay. When we have a coefficient in front of a variable, we'll just find the limit of the variable itself and then multiply that limit by the constant after, which means we would do the exact same thing here. And if we have an exponent, same idea, we find the limit of x. Once we have that value, we put it to the squared and then multiply it by the constant. So this polynomial addresses 1, 2, 3 major properties of limits. And we didn't go into too much detail of them because you're going to see that with a polynomial it's relatively easy. Now, it seems that as x approaches 2, the limit of the limit of 3x squared would be roughly what value? Anyone know? 12. Okay? Which is essentially the value of just plugging 2 into this. We get our value of 12. It would seem that the limit when x is approaching 2 of negative 4x, write that in, is what value? Equal to negative 8. Again, the idea of we're just plugging our value of 2 into it. So when we go to simplify this, the limit of x as it approaches 2 seems to be 12 minus 8 plus 2, which is the value of, anyone?
6.
Perfect. Okay, so it could be said that for a polynomial, which is a value like this, that the limit of f at a is equal to the limit of f at x. Okay, and the idea is that we just plug in our values and we get our limit in the end here. Okay, so with that being said, this is a rational function. Okay, we quickly see that we can find the limit of x squared, limit of 5x, and these two are constants, so these values stay the same. We have to find the limit of 4x squared and the limit of 6x. For the most part, we're simply plugging our values in because nothing is becoming discontinuous in these limits themselves. Okay? So because nothing is discontinuous here, we can plug these values in and get what the limit would be at that number. So when we go to plug this in, we have the idea of the limit as x approaches 1 of 1 squared plus 5 times 1 plus 2 divided by 4, 1 squared minus 6 times 1 plus 1, which gives us the limit of x as it approaches 1. Is that what it is in the end? Beautiful. Great. You guys are awesome. Negative 8. Okay? So limit as x approaches 1 is negative, which is essentially just evaluating everything here. We didn't have to go into any specific strategies to make things simpler for us because these were continuous. And finally, we have a root function. Okay? Root function here. Again, with our properties, we would technically evaluate the limit of each of the variables involved. The constant stays the same, and then we would apply the squared and the root at the very end. But the idea is we can just plug these values in again. So the limit of x as it approaches 5 becomes 5 squared over 5 minus 1, which is the root of 25 over 4, which is our 5 over 2. Okay? So for questions like these where we don't have, oops, that's the wrong button. There you go. Where we don't have anything being discontinuous, our limits are essentially the values plugged directly into our equations of polynomials. Okay, so something a little more difficult to solve. We have our limit of 3. Well, if I plug 3 directly into this, I have an undefined function, which means we have what's probably a hole in this function here. Okay? So we still want to evaluate the limit, and instead of trying to approach 3 from the left and the right, we're going to try to simplify this function to help solve it. That's exactly right. So we're going to factor our numerator here. If you guys recall factoring, x squared minus 2x minus 3 breaks into x plus 1, x minus 3, right? So that leaves us with limit of x as it approaches 3 of x plus 1, x minus 3, all divided by x minus 3, which means we could simplify this function by eliminating these two. We're then left with x plus 1, and we can now put in our value as x approaches 3. Our limit looks like it is the value of 4 in this question. Okay? So when we are approaching the value of 3, y would be approaching our value of 4. Okay? Same idea. Oh, I need to get a value here. 0, I'd imagine. Okay, so the limit as x approaches the value of 0. Again, we cannot just plug directly in because we are undefined at that point of 0. So we want to find out our limit. What value are we roughly approaching at this point? Now, if you guys recall from 1.1, we talked about rationalizing a function. Upgraders, you guys weren't here, but if we're going to rationalize this function, we're going to multiply the numerator and the denominator by our root plus our value of 1, okay? And we would use the opposite operation from what was there. So we're using a positive value because there is a negative here. And this is the opposite idea of difference of squares. We're essentially doing the reverse of it, okay? And whatever we do to the top of a fraction, we must do to the bottom. So x plus 1 plus 1. When we multiply these out, the limit of x as it approaches 0, on top, what's going to end up happening is we're going to have x plus 1. Okay, when we multiply this, think of this like distributive property. When we multiply these two, the roots will disappear. We have x plus 1. The values in the middle would all cancel out, and we have negative 1 times positive 1, which gives us a value of negative 1, which is our new numerator. Our denominator is now x multiplied by the root of x plus 1 plus 1. Up here, these cancel out, and we can then also cancel out our x from the top and the bottom. Okay, and when we say cancel out, we create a 1. So our value is now 1 on top, and on the bottom we have the value of root x plus 1 plus 1. Now at this point, we can now substitute in our value of 0. If we substitute 0 in, we're looking for the root of 1, which is 1. And then 1 plus 1 is 2, so the limit of x as it approaches 0 is a half.